So as I have told, electric dipole, these concepts are very important, especially electric dipole. Electric dipole consists of two charges of equal magnitude and opposite in signs. The charges are separated by a distance of, I can write 2L or 2A. Now look at this boys. The strength of an electric dipole, to what extent the molecule can be polarized, that is what the strength of an electric dipole is measured by a quantity called electric dipole moment. If at all you have a numerical, right? In all these cases, this is very important. Please start writing. Define electric dipole moment, state its SI unit. This might come as a definition based question, right boss? The strength of an electric dipole, to what extent a polar molecule can be polarized, that is what is the electric dipole moment. The strength of an electric dipole is measured by a vector quantity, what we call it as electric dipole moment. Now it depends on, can you see this boys? It depends on the magnitude. Yes, boy.
Could you repeat the question, please?
Define electric dipole moment. Should I write? Define electric dipole moment. State its SI unit. Boys, if you have a dipole, it will have a positive charge, it will have a negative charge. Right? To what extent the molecule can be polarized? Polarized means you should have a positive charge and negative charge far apart. Right? Completely polarized, we call this as. To what extent the molecule gets polarized, right? That determines its strength, and that depends on the magnitude of the charge and the distance between them. Is that clear, boys? Please do write, very, very important. Define electric dipole moment, state its SI unit. So how will you define? It is defined as the product of the charge Q and the separation between the charges, right? It is defined as the product of the charge, any one charge, right? And the separation between the charges. It is a vector quantity because charge is not a vector quantity, which means the distance you measure between the charges is a vector quantity. Vector quantity means it is a direction dependent. So all your dipole moment will be pointing from negative charge to the positive charge. The direction is from negative to positive charge. Now look at the SI unit. Q, the charge has an SI unit of coulomb, right? The distance has an SI unit of meter. So coulomb meter, is that clear, boys? So what is electric dipole moment? It is a product of any one charge constituting the dipole into the distance between them, between the charges. And it is a vector quantity. Electric dipole moment is a vector quantity. It always points from the direction from negative charge to the positive charge. SI unit is coulomb meter. Because today I have to do two derivations because in the other class 12C I have completed a numerical based on electric dipole moment. Today I'll be completing the derivation part, but I don't think so I'll be able to solve the numerical this class. So what I'll do is I'll finish up the derivation. Then if time permits, I'll solve the numericals.
Do you have to write the derivations?
Yes, boys, it's very important. That's what I'm making you to write. So it's define electric dipole moment, state its SI unit. Please be bit fast, boys. Just you have to specify the direction. P vector is always from minus Q, the charge, to the positive charge. Have you completed?
No, 1 second.
Okay. Surya? Surya? Yusuf?
Can you hear me?
Oh, yeah, sure.
Yes.
I'm speaking to Yusuf, right?
No, ma'am, Sudhya.
Okay. Yusuf?
Yes, ma'am.
Okay. Was completed. Have you completed, boys? One second.
Yes, ma'am.
One second.
Ma'am,
Yes, boss.
ma'am, I had a doubt about the activity that we had to do, the investigatory project. Does it have to be something that we make, or can it be an experiment also?
No, you can have it as an experiment also. One second, boys.
Okay.
One second. Tomorrow, sir will be taking up your class. Can you see the textbook which I am showing you?
Yes, ma'am.
Can you? Okay, right, boys. Now, actually, what has happened is that electric flux comes first as per your textbook. Your electric flux, electric field lines that we have completed. Then comes electric flux. Then comes your electric dipole. Now, why I have shifted electric flux later? Because you will be having application based on electric flux. So that theoretical part you will understand only when you understand your electric flux. So I'm completing electric dipole, then I'll go for electric flux, then I'll go for applications. Now look at this. Can you see the textbook which I'm highlighting? Sorry, I'm showing on the, okay. Now electric dipole, an electric dipole is a pair of equal and opposite charges, Q and minus Q, separated by a distance of 2a, right? Now, the midpoint of the location is called the center of the dipole, right? The direction minus Q plus Q is said to be the direction of the dipole. So boys, once I complete this chapter, whatever are important concept like this, I'll highlight and I'll send this file to your email ID. So when you're going through your textbook, you have to go through your textbook, boys. So whatever is highlighted, you have to learn, right? Now look at this. The total charge of the electric dipole is obviously 0. Is that clear, boys? Is that clear? This does not mean that the field of the electric dipole is 0. Are you clear? Though the total charge is 0, see electric field, what is electric field? 1 by 4 pi epsilon naught Q divided by R square, right? If Q is 0, Q is the charge. If Q is 0, the electric field should also be 0. But here, though the total charge is 0, it doesn't mean your dipole is not creating an electric field. Is that clear? Is that clear, boys? Now,
Yes.
the electric field due to a dipole falls off at large distance. So if you consider an electric dipole, it creates its own electric field. The strength of the electric field due to a dipole, right, becomes weaker and weaker as you're moving away from the dipole. So all these concepts are very, very important, boys. So once I'll highlight let us complete this chapter, whatever is to be highlighted, I'll highlight and then I'll send it to you. Right. So your email, you can go through it. So keep this in mind, though the total charge of the dipole will be minus Q plus Q, that becomes equal to 0. Though the total charge is 0, but still the dipole will create an electric field. The strength of the electric field, right, becomes weaker and weaker as you're moving away from the dipole. Is that clear? Right, boys. Now, the electric field of an electric dipole can be found from the two, one Coulomb's law and the other one superposition principle. Are you clear, boys? If you have a dipole, the dipole will create an electric field. If you want to find the strength of the electric field, you have to use superposition principle as well as Coulomb's law. Then you are finding the strength of the electric field. There are two cases. What are the two cases? Suppose a dipole produces an electric field. You want to find the strength of an electric field at a given point. Now, the points can be one along the dipole axis. Look at this in the two cases. Whatever I'm highlighting, are you able to see? 12C, so 12B?
Yes,
ma'am.
Yes, ma'am.
When the point is along the dipole axis, so the point where you want to find the strength of the electric field produced by the electric dipole, this point can be along the axis of the dipole and it can be along the equatorial plane of the dipole. What is an equatorial plane? A plane perpendicular to the dipole axis passing through its center. So keep this in mind. Though the total charge of an electric dipole is zero, it creates an electric field, right? And the strength of the electric field keeps on decreasing as you are moving away from the electric dipole. Now you are going to find the strength of the electric field due to a dipole using two laws. One is Coulomb's law, the other one is superposition principle. Now, where are you going to find the strength of the electric field? Two cases. One is you're going to find the strength of the electric field at a point, right, along the axis of the dipole, and one more at an equatorial point. Now, what is an equatorial point? An equatorial point lies on an equatorial plane. Now, what is an equatorial plane? A plane perpendicular to the dipole through its center. So, as you go, we'll analyze it further, boys. Okay? So, today's session is you're going to find the strength of the electric field due to a dipole, one along the axial point, the other along your equatorial point. Is that clear, boys? Is that clear?
Yes,
Yes.
Yes, ma'am.
So now onwards, boys, whatever is being highlighted, I'll share the paper with you. Sorry, the online text version with you. So when you're going through your textbook, once at least you should go through your textbook. As you're going through your textbook, you should know which are the points. Why I'm stating this is your reasoning and assertion based question. All you can attempt all your reasoning and assertion based question once you are very thorough with your text material, right, boys? Now, please, those who have completed, please start writing. Electric field, right, boys? Electric field intensity. Electric field intensity at a point. Electric field intensity at a point on the axial line of an electric dipole. On the axial line of an electric dipole was very, very important pre-mark question from the theory point of view. Is that clear, boys? Okay. Now let me consider an electric dipole, boys. I'm just drawing. Now let me consider a dipole of charge minus Q and a charge plus Q separated by a distance of 2a meters. Is that clear? Right? Now let O be the center of the dipole. Boys, let this distance will be, because O is the center, means this distance will be A. Right? Now let me find the strength. Can you imagine? Are you getting this dipole, boys? You're getting this dipole. So the dipole is from A to, you have a charge minus Q and plus Q. Right? The length of the dipole is 2A. So that O is the midpoint. I want to find the strength of the dipole at a point P, which is lying along its axis. right? That is why we call this as the axial line, and the point P where you want to find the strength, right? It's lying along the axis. Now this point is at a distance of r meters. This point is at a distance of r meters from the center of the dipole. Can you first draw the diagram, then we'll go for the definition part. So the introductory part. Is that clear, boys? 12B, is that clear?
Yes, ma'am.
Yes,
Fine.
ma'am.
So you have a dipole consisting of two charges, minus q and plus q, separated by a distance of 2 meters. You want to find the strength of the electric dipole at a point P, which is lying along the axis of the dipole, and it is at a distance of r meters from the center of the dipole. So first draw the diagram and then write the statement, then we'll go stepwise. Very, very important concept. Boys, those who are not going for coaching classes, those who are not going for coaching classes, any of your coaching classes, please put a message so that on Saturdays, in case I'm not going to take theory because the other students will not be there, textbook numericals as well as board-based numericals, application-based question, I'll keep a class in Teams so that if you're not getting any help from anywhere else, the additional numericals I'll solve along with you. This is for children who are not going for any coaching class, right? Who are learning by themselves. Even others, even for that matter, others, if you have time on Saturdays, you also can attend. It's not that I'm stopping you, but those children, because don't keep it at the end, boys. Now you select, you give me a time, boys. For me, it doesn't matter. Just put a message in, right? You know where to write a message. Just put a message. 3 students, 2 students, no problem. I'll start the class because we should not prolong it, boys.
Ma'am.
Yes, boys.
Ma'am, charge is a scalar quantity, right?
Charges are scalar quantity.
Okay, ma'am.
Okay, fine. Please draw the diagram. Just write the statement. Because writing the statement is very important. So you want to calculate the electric field E at a point P on the axial line of the dipole. Here I have written, right? Consider an electric dipole consisting of two charges, minus q and plus q, separated by a distance of. Or shall I skip that and later on will you write, boys, or you want to write? Because if you don't write these things, they will reduce your marks in your board exam.
I will write now.
Okay, okay. Should I read out so that it will be easier for you to copy down? Should I read out, boys, instead of you looking at it and copying? 12B? Fine. Now look at this, boys. You want to find the strength of the electric field where at point P due to the entire dipole. Now what we'll do is, let us find the strength of the electric field at point P due to the charge at A. Is that clear, boys? Let me find the strength of the electric field at point P due to a charge placed at point A, right? Now, for that, what should I do? I have to place a test charge. I have to place a test charge.
Yes, ma'am.
Yes, ma'am.
Say of plus 1 coulomb here, right? The magnitude of the force it experiences gives you the strength of the electric field. Because if I only don't think of the other charge, only consider the charge which is at point A. I'm considering only the charge which is at point A. Now this is going to create an electric field at point P. Now what is the strength of the electric field at point P due to the charge minus Q at A? For that, let me place a charge of +1 coulomb test charge at point P. Now this will experience a force of attraction or repulsion. Attraction or repulsion. Was this test charge +1 coulomb will experience a force of repulsion or attraction. So then, and the force and the field will lie like this, right? Now, can you understand the arrow what I have written? This is
Yes, ma'am.
This is EA vector. Is that clear, boys? Is that
Yes,
clear?
ma'am.
Same diagram.
Ma'am, so
Okay,
in the
now tell
diagram,
me.
should we add
Yeah.
these two?
Yeah, you have to add. Keep adding. Your diagram should be complete, then we'll know what it is.
Ma'am, EA vector is between B and P, right?
Huh?
EA vector is between
No,
point.
no, it is acting from, because the charge at point P is 1 coulomb. That will be pulled towards the charge minus Q coulombs. It is acting from A to P. It goes from, sorry, it is acting from P to A. It goes, are you clear? Are
Yes,
you
ma'am.
clear, boss? It's, forget about B. Forget about B. It's only about the charge at minus Q and the point P. It will, this charge at point P, that is +1
Ma'am,
coulomb, will
and
be
2A is from A to B, right?
what's that?
2A is from A to B.
Yeah, the distance. Okay. The distance is between the two. Okay, fine. Next, I have to find the strength of the electric field at point P due to which charge? The first one we have already taken. Which charge?
Ma'am, due to B.
Yeah, it should be the charge. The strength of the electric field at point P due to the charge at A we have already found. Now I have to find what is the strength of the electric field at point P due to the charge. Which charge? Charge plus Q. So will it be a force of repulsion or attraction?
Repulsion.
Now it is between plus Q and +1 coulomb. Will it be force of repulsion or attraction?
Repulsion.
Others, are you able to understand? Kavin? So this should be equal to EB vector. Is that clear?
Yes,
Clear?
ma'am.
Is that
Yes,
clear?
ma'am.
Hitesh, is it clear?
Yes, ma'am, clear.
Diagram is very important. Once you understand the diagram, it's fine. Now what we have to do is, you have electric field strength EA, you have electric field strength EB. So I want to find the total electric field strength at point P due to the entire dipole. So what should I do? I have to add these both, right? Should I add this? Vector sum, no?
Yes, ma'am.
Ma'am.
Yes, ma'am.
So now first let us find EA, then let us find EB, and then we'll see. Okay. Now electric field at point P due to a charge at minus Q at A. Boys, now what you have to do is, shall I erase the first diagram? Is it difficult for you to understand? Okay, fine. I'll go for this. Now here, what I'll do is, just B is there. Don't worry about this point B. I'm just taking this point A. So here I have a charge minus Q. I'm going for this point P, right, boys? Here it is +1 coulomb. Here it is minus Q. Now what is the distance between them? So what is the force between these two charges, right? I have to go for the force between these two charges. What is the electric field strength? EA will be equal to, I'll go for the vector. What is the formula, boys? 1 by 4 pi epsilon naught. Which charge is creating the electric field? Which charge is creating the electric field?
Minus Q.
Minus Q. I'm just taking the magnitude only. So I'll take this as Q divided by AP squared, because the distance is between these two. Minus Q and plus 1 coulomb. So it is AP squared.
Yes, ma'am.
Okay, acting along which direction? Is it from P to A, or is it from A to P? Look at your EA vector. This is EA vector. No, EA vector is this.
Oh, sorry, ma'am. P to A.
So it will be along
P to A.
Okay, along PA. Is that clear, boys? Because if you can understand, there's no need for this diagram. Okay. Can someone tell me what is AP? What is the value of AP? What is the value of
A plus
AP? Okay. So it is from A to P. Can you check your diagram, boys? So from A to P, it is from O to P, it is R, then P to O, O to A is A, so it will be AP. Look at the distance AP, it will be A plus R plus A the whole square. Yes?
Ma'am, you're calculating the vector or the modulus?
Which one was?
Ma'am, over here for EA, you're calculating the vector or only the modulus?
Modulus. Okay. So.
Okay, ma'am.
So, but still I'll put the direction from P to A. Okay. I'll put the direction from P to A. Is that fine? Still anyone finding it difficult, boys?
No, ma'am.
Could I highlight the distance between P to A? This one is P to O and this one is.
Ma'am, if you were doing the vector, like not just the modulus, then should you put minus also then? Because
Which one?
I'm
Not
like
this.
so.
No need.
Okay.
Shall I go for the next one? Shall we find EB?
Yes, ma'am.
Can someone put this slide on your chat box? Dheeraj, Fadil, Farhan, is that fine, boys? Shall I erase this, boys? Shall I erase this entire thing?
Yes,
Yes, ma'am.
So we'll go for the next one. Now we need to find what is the strength of the electric field at point B due to the charge. So now this distance O to B is R, correct? O to B is A. So what is that? EB is equal to 1 by 4 pi epsilon naught. The charge is Q divided by PB squared. Now that will act from B to P, from B to P. Is that fine? So what is PB squared? Can someone tell me what is PB squared from the diagram? Or what is PB? What is the value of PB?
R minus A.
Yes, who's telling?
It's me, Jatin.
Jatin, correct. It is R minus A. Jatin, is it R minus A?
Yes, ma'am.
Okay, correct. R minus A the whole square. Thank you. From B to P. Now you have to judge, boys. Look at this. I'll just highlight this. Fine. When see both the vectors EA and EB are acting in opposite direction. Both the vectors EA and EB are acting in opposite direction. If they act in the same direction, then the total electric field will be EA plus EB. Now both are acting in the opposite direction. So in that case, you have to subtract one from the other. Which one should I subtract? From one from the other. The net electric field E is equal to, is it EA minus EB or is it EB minus EA?
EA minus EB?
EB minus.
Okay.
EB minus
EA. Which point? Yeah, which point is, yes, correct. Which point is closer? Which charge is closer to the point P? Which charge is closer to the
B,
point P? B.
plus
So then,
Q.
yeah, then that electric field EB will be greater than EA. Is clear, boys? Which charge is closer? Whether charge positive Q or negative Q is closer to the point P. Which is closer? Closer, the strength will be more.
Positive Q.
Positive. So EB is greater than EA, boys. The magnitude of, I'll just put. So then it will be vector addition, boys. EB minus EA vector. And put the vector sign. We don't take, since you have put the direction, otherwise I have to use a unit vector. So now can you find this, boys? 1 by 4 pi epsilon naught Q divided by R minus A the whole square minus 1 by 4 pi epsilon naught Q divided by R plus A the whole square. Net electric field will act from which point to which point? Which vector is greater? EB is greater. So the net electric field will be in the direction of EB. EB is from which point? EB is acting from point B to P. Are you clear? Are you clear, boys? 12B,
Yes.
Jokol,
Yes, ma'am. It's clear.
Jonathan, Johan,
Yes, ma'am.
will you be able to, which are the common
How
factors?
is EB bigger, greater?
Hmm?
How is
EB is
EB?
greater because the charge plus Q is closer to point P rather than the charge minus Q. See, both the charges plus Q and minus Q are creating the electric field. Both the charges are creating the electric field. Are you clear? Both are creating the electric field. But the charge which is closer to the point P, their strength of the electric field will be more, right? See, when you're very close to the poles of the bar magnet, then the magnetic force will be greater. If you're far away, from the magnet, then the force you experience will be less. Point P is closer to B plus Q, the charge. That is why EB is greater than EA. Which is your sorry, boys? Which are the common term over here? Take the common term outside. So it will be 1 by R minus A the whole square minus 1 by R plus A the whole square. I think so now you people know how to. Siddharth, can you put this slide onto your chat box so that I can go for the next? Samuel,
Yes, ma'am.
Sanfa, okay. Samuel, Sanfa, fine. Samuel,
Yes, ma'am. It's clear.
okay. Now, mathematics students, you know how to solve 1 by R squared minus A squared minus 1 by R plus A the whole square. I'll give you 2 minutes, solve this. Should I go for the next slide or should I wait here? Boys, should I go for the next slide or should I wait?
Ma'am, next slide.
You can go.
Okay. Okay, now you just tell me what, sorry, what was, I'll just put- so E vector will be equal to Q by 4 pi epsilon naught into 1 by R minus A the whole square minus 1 by R plus A the whole square. So let me take this Q by 4 pi epsilon naught into denominator R square minus A square the whole square, correct boys? R plus A the whole square minus R minus A the whole square. So let me go for it. So this will be Q by 4 pi epsilon naught. So numerator R square plus A square plus 2AR, right boys? Minus R square plus A square minus 2AR divided by R square minus A square, the whole square. Is that clear? So then what is that you are going to get? 1 by 4 pi epsilon naught into R square plus A square plus 2AR minus R square minus A square plus 2AR divided by R square minus A square the whole square.
Yes,
Are you all getting that? Okay, fine.
Yes.
These two terms will get cancelled. Is that fine? So I'm going over here, boys. I'm taking this step to here. So E becomes the net electric field. Will become Q by 4 pi epsilon naught into 4AR divided by R square minus A square the whole square. Only small rearrangement let us do. These two terms will slightly rearrange. So E becomes equal to, boys, I can take Q into 2A. Then what is left here? 2R, correct? By 4 pi epsilon naught into R square minus A square, the whole square. Look at this. What is this? This is your electric dipole moment. Since P is equal to
Yes, ma'am.
Q into 2A. So what happens to E? E becomes equal to 1 by 4 pi epsilon naught. Correct, boys? P into what is left? 2R divided by R square minus A square, the whole square.
Ma'am, now can we cancel 2 and 4?
Which one? How can you?
2 and 4 from numerator.
No need, boss. Let it be a standard. The reason is sometimes if you solve your numerical, what happens? 1 by 4 pi epsilon naught. The value is 9 into 10 to the power of 9. That's
Right.
the reason.
Should we write the direction from P to P?
No, I'll do that. Let us complete this, then we'll go for the direction.
Okay, ma'am. Also, ma'am, why did they write the if the length
Yes.
of the dipole?
What happened, Jonathan? That the last one was, that's a special case. I'll do that later. So copy down this. Was others, are you able to follow Muzamil, Danish,
Yes, ma'am.
Nabil, Sanfa?
Ama?
Are
Yes,
you
ma'am.
are you able to send Vishesh?
Ma'am?
Yes, Jonathan?
Ma'am, P should be a vector, right?
No, I'll do that. Let me finish this. Then there's no
Oh, okay.
space for me to do this.
Oh,
I'm
okay.
putting it at the end. I think so. The slide is not. We'll do it at the last. Okay. So let us go for the special case. Yes, boys.
Ma'am, nothing is not clear. You asked me.
My voice is not clear.
My side is all clear.
Okay. Generally, it's not clear.
Ma'am, all clear.
No, ma'am. Vishesh, ma'am, you called Vishesh. He's just answering.
Ah,
the
yeah,
call.
correct. Oh, okay, okay, fine, fine. I thought
Ma'am, what happened to 2A?
no. Q into 2A is your dipole moment. This is your electric dipole moment. P is your electric dipole moment. If you have completed, just let me know because certain things I have to erase and go for the special case. Shall I?
Yes, ma'am.
Shall I? Okay. Others, shall I? Or should I wait?
Yes, ma'am. Yes, ma'am. You can go on the
Ma'am,
pictures
it's
and
there,
chat
the
box.
chat. Yeah.
Okay. Now go for the special case, boys. If the dipole is very small compared to the point P, if the point P is lying far away, right? And the dipole is very small. Now, what do you mean by that? One second, students. Suppose if you have the dipole, boys, you have the dipole A, have a short dipole. The dipole is very short, AB, right? This distance is 2A, but the point P is somewhere over here. So this distance is R. Compare these two distances. If R is very much greater than A, which means the dipole is very small, then I can neglect A. I can neglect A, the term neglecting A. Then what happens to this equation? If you neglect A, what will happen? E becomes equal to 1 by 4 pi epsilon naught E into 2R divided by, I have to neglect A. Are you clear, boys? The distance R is, say, it is like this. If distance R is 1000 meter, if the distance A is 1 millimeter, then 1000 meters, I'm talking about meters, 1000 meters minus 1 millimeter, will it make a difference? Will this make a difference?
No, ma'am.
Yeah, that's what. That is the reason you're neglecting A. So in the, where you are neglecting A, you're neglecting A in your denominator. This is your denominator part. You're neglecting A. So then what happens? R squared, the whole square. Is that correct, boys?
Yes.
Correct.
So,
Copy down. So what will you get?
We'll get 2p by 4
E is
pi.
equal to 1 by 4 pi epsilon naught P into 2R divided by R to the power of 4. So shall we cancel this? So
Yes.
E becomes equal to 1 by 4 pi epsilon naught 2P divided by R cube. If I go for the direction, then E vector will be equal to 1 by 4 pi epsilon naught 2 P vector by R cube. And I can put R cap also. This is your final answer. Let's just check how many minutes left.
Ma'am, 4 minutes.
4.
Okay. Ma'am, it should be RPA.
R?
PA.
Or else if you don't use R cap, you can write directions from B to P, no? Because it's the total electric field will be acting along the direction EB vector, because EB vector is greater than EA vector. If you find this difficult, or if you feel this difficult, I can write along BP, B to P, correct?
Got it, ma'am. Thank you.
Next one, at least the diagram part I'll start.
Sure, ma'am. You can go ahead with that.
Equatorial, boys, I'll just explain what is now. In the previous case, you had found the electric field strength at a point on the axial line. Now, what is that you're going to find? Suppose if I, now this is your dipole. So let me put this as your dipole. So we mark this point. This point is A, which has a charge minus Q. This point B, this has a charge of plus Q. This is your dipole. The total distance is 2A. Right, boys? The central point is O. Now, what is an equatorial plane? Any plane which is perpendicular, a perpendicular plane, and this plane should be perpendicular to the axis. You know what is the axis of the dipole? Along AB. So this is an equatorial plane. If I want P is a point on the equatorial plane. So this point P, we call this as equatorial point. Is that clear, boys? Point P is called the equatorial point because it is lying along the equatorial plane. Now, the distance between the center point and center of the dipole and the point P where you want to find the strength of the electric field, boys. P is a point where you want to find the strength of the electric field due to the entire dipole. And this point is lying along the equatorial plane, a plane which is perpendicular to the axis of the dipole. Are you clear? Are you clear? If I want to find, now how will I find? Now we have to go for finding the strength of the electric field at point P. First, due to a charge minus Q at point P. So what should I do? I have to place a charge of 1 coulomb over here. Is that correct, Sanfa? Sanfa, I want to find the strength of the electric field due to the entire dipole. That has two parts. One is you find the strength of the electric field at point P due to the charge minus Q. Then you find the strength of the electric field at point P due to the charge plus Q. Is that clear, Sanfa?
Yes, ma'am, it's clear.
Okay. Now look at this. Was in that case, now in which direction will the force?
Is it possible next class also you can draw the diagram?
Yeah, I'll draw. But anyway, I'll just explain and then I'll move. Might be sir might be continuing. I am not very sure where because it might be a combined class. So sir might combine with his class. I don't know whether sir might have completed this part. If sir has completed this part and if sir is taking a new topic, you go along with sir. Then once I'll come back, might be in April. I'm not very sure, boys. This timetable is going to change, right? Your timetable is going to change. I don't know. So let us see.
Now it's already 9:55.
Okay, fine.
All right, ma'am.
So,
Thank you.
so I have finished till this. So whoever comes as your teachers next, just check with them and then we'll go. Fine, boys.
Okay, man. Thank you.
Continue, please.
Thank you, ma'am.
Thank you. Thank you.